In this video, we are going to look at factorizing these three equations. Before we get started, we have to look at a couple of things. One is how to expand two brackets, or commonly called foiling the brackets, and the form that a quadratic takes is ax squared plus bx plus c. We are going to split this factorizing into two parts. One where the a is equal to 1, where a is the coefficient of x squared, for example x squared plus 3x plus 2, and another where a is not equal to 1, for example 2x squared plus 5x negative 12. FOIL stands for first, outer, inner, and last, and this technique is used to expand two brackets that have two terms in each of them. Terms are separated by a plus or a minus. I FOIL a bit different, but in essence it is exactly the same. It just makes it easier for me to visualize factorizing quadratics. We start off by multiplying the first two terms, being x times x. Then we multiply the last two terms, being 2 times 1. Then we multiply the inner two terms, being 2 times x. And lastly, we multiply the outer two terms, being x times 1. Simplify your expression. X times x is x squared. 2 times x is 2x. X times 1, you can just write it as x. And 2 times 1 is 2. Add the 2x and x, and then you have successfully expanded the brackets, and your answer will be x squared plus 3x plus 2. Let's try to FOIL another set of brackets. Exactly the same as before, we multiply the first two terms, 2x times x. Then we multiply the last two terms, negative 3 times 4. Then we multiply the inner two terms, negative 3 times x. Then finally multiply the outer two terms, 2x times 4. Simplify the expression. 2x times x is 2x squared. Negative 3 times x is negative 3x. 2x times 4 is 8x. And negative 3 times 4 is negative 12. Subtract 3x from 8x, and then you have your answer, which is 2x squared plus 5x negative 12. Now that we can FOIL or expand the brackets, we can move on to factorizing quadratics. The first example is factorizing x squared plus 5x plus 6. We now know that factorizing a quadratic will result in two sets of brackets, having two terms each. Terms yet again are separated by a plus or a minus. We start off by looking at the last term, the positive 6, and we need to find a set of numbers that when they multiply with each other, the answer should be positive 6. 1 times 6 is 6, negative 1 times negative 6 is 6, 2 times 3 is 6, and negative 2 times negative 3 is also 6. Now that we have our sets of numbers, we can shift our focus to the coefficient of x, which is 5. We now need to find a set of two numbers that when they are added to each other should give us positive 5, the coefficient of x. 1 plus 6 is not 5, so we can't use this set. Negative 1 minus 6 is also not 5. But 2 plus 3 is 5, so we can stop there and use the positive 2 and positive 3 in our calculations. Substitute the positive 2 and positive 3 into the brackets like so, and there you have factorized the expression. It doesn't matter which bracket comes first, it can be the 2 or the 3. The second example is factorizing x squared plus x negative 12. We know from earlier that by factorizing the quadratic, it will take this form. So exactly the same as the previous example, we need to find two number sets that when they are multiplied to each other should give us negative 12. 1 times negative 12 is negative 12. Minus 1 times 12 is negative 12. 2 times negative 6 is negative 12. Negative 2 times 6 is negative 12. 3 times negative 4 is negative 12. And lastly, negative 3 times 4 is also negative 12. And there we have all of our sets of numbers. Now, shift your focus to the coefficient of x, which is 1, because x is the same as saying 1x. Now we need to find a set of two numbers that when they are added to each other should give us positive 1. 1 plus negative 12 is not 1. Negative 1 plus 12 is not 1. 2 plus negative 6 is not 1. Negative 2 plus 6 is not 1. 3 plus negative 4 is not 1. But negative 3 plus 4 is equal to 1. So we need to use the set of numbers, negative 3 and positive 4. Substitute these values into your bracket. Any bracket can be first, as long as the one bracket is x negative 3 and the other bracket is x plus 4. This is where the factorizing gets a bit different, when the coefficient of x squared is not equal to 1. In this case, it is equal to 2. With our knowledge of foiling brackets, we can say that the factorization will take this form, because multiplying the first two terms, 2x and x, will give us 2x squared. Multiply 2 and negative 6, and this will be our number to determine our set of numbers, which when the set is multiplied by each other should give us negative 12. 1 times negative 12 is negative 12. Negative 1 times 12 is negative 12. 2 times negative 6 is negative 12. Negative 2 times 6 is negative 12. 3 times negative 4 is negative 12. And finally, negative 3 times 4 is negative 12. There we have our set of numbers. Now shift your focus to the coefficient of x, which is negative 1. So we need to find the set of numbers that when they are added to each other should give us negative 1. So we can go through the list again. 1 plus negative 12 is not negative 1. Negative 1 plus 12 is not negative 1. 2 plus negative 6 is not negative 1. Negative 2 plus 6 is not negative 1. But 3 plus negative 4 is in fact negative 1. So we need to use this set of numbers. Write the expression again, but write down negative 4x plus 3x instead of negative 1x. You can write it like this because it says exactly the same thing. Because in our original expression, the coefficient of x is negative, we put the smallest or the negative number first in our expression. Factorize the first two terms and the last two terms by taking out the highest common factor. 2x is a common factor of 2x squared minus 4x, and 3 is a common factor of 3x minus 6. Here we can see that we now have a pair of brackets that are the same. So we can factorize it further by putting the 2x and positive 3 in brackets and multiply this bracket by x minus 2, also in brackets. You can put any one of these two brackets first, it doesn't matter. One important reason why we factorize quadratics like this is to find the roots of the quadratic, also called the x-axis intercepts. To find the roots, we need to make the expression equal to 0, because when y is 0, your x values will be the roots. If any of the brackets are equal to 0, then anything multiplied by 0 will be 0. So you can say 2x plus 3 equals 0 and solve for x. And then you can say x minus 2 equals 0 and also solve for x. These two answers for x will be your x-axis intercepts, like so. Thank you for watching, and I hope you understand factorizing quadratics a little bit better now. Good luck on your math journey.